Hi everyone, this is Dr. Nock. So we're going to go over section 7.1, angles and their measure. So first, let's go with the definition. A ray, or the half line, is the portion of the line that starts at a point V on the line and extends indefinitely in one direction. When two rays are drawn with a common vertex, they form an angle. Starting side is called the initial side and the ending side is called the terminal side. Okay, so the important part is that if the rotation is in the counterclockwise, we say that the angle is positive, and if it's the other way around, which will be clockwise, the angle is negative. So let me just start drawing some pictures to explain. So first, let me just draw this dot. Now this is called the vertex. And, oh my god, pretend that's a straight line, please. All right, so this line is called the initial side. And let me just draw it like this. Now, this side is called the terminal side. And our angle alpha is in between these two. Let me just write alpha is the angle. And we say that the angle theta is in standard position if the vertex is at the origin. Okay, so let me just show you which angle is going to be positive and which angle is going to be negative. So, okay, so suppose this is the origin, and let me just change the color here. Now suppose this is the initial side, and let's go over here is the terminal side. Okay, then if I measure an angle from the initial side to the terminal side, so let's just call that angle theta. Now in this case, since starting from the initial side to the terminal side, you're gonna have to move counterclockwise. So in this case, our theta is positive. And furthermore, theta lies in quadrant 2. So it's this little notation, like a little tiny e. That looks really ugly. Let me just redo that. Okay, so this little e means theta is inside of, or theta is in quadrant 2. I use that notation quite often, so I just wanted you to get used to that. All right, now let's go with the negative angle. Okay, so again, this is our initial side. And then let's just make this side is the terminal side. Then if we form an angle from initial side to the terminal side, and then again, let's just call that angle theta. In this case, since we're revolving clockwise from the initial side to the terminal side, in this case, our theta is negative. And theta lies in quadrant 4. Now, if theta lies either on the x or y axis, that could happen. So let me just draw the picture. Okay, so this is the origin, and let's see if this is going to be our initial side, and suppose this is going to be our terminal side. Now, let me just draw the angle starting from the initial side to the terminal side and counterclockwise. Now let's just call that guy theta. So is theta positive or negative? Since we're revolving from the initial side to the terminal side counterclockwise, we know that theta is positive. And also when theta lies on the x or y axis, it has a special name. Your theta is going to be called a quadrantal angle. So I will write everything out. So when theta lies on the x or y axis, we say that theta is quadrantal angle. You just have a special name, and that's all. Okay, so now let's go with our degree measures. So degrees. I'm pretty sure you're sort of familiar with it. So when we say 1 degree, the notation will be 1 degree, a little circle on top. Now that is same thing as 1 over 360 revolution around the circle. Okay, so please memorize this. This is important. Okay, so let me just give you some examples. So let me just go with, suppose that, let me change the color. Suppose this is going to be both of our initial and also the terminal side. Terminal side. And then our angle theta is going, suppose it's going to start from the initial side and then it's going to end on the same line. So in this case, let's just call this guy theta again. In this case, 1 revolution is nothing but 360 degrees. Okay, now suppose that this is going to be our initial side. And suppose this is going to be our terminal side. I'm just going to write it as term. All right, and suppose that this is a right angle, which is a 90-degree angle. So in this case, our theta is 90 degrees, and then this guy also has a special name. It is called the right angle. Okay, now another case will be this. So suppose this is the center. Here is my initial side, and suppose the terminal side is going to be on the other side. I'm just going to write it as term, and then our angle theta is going to go from initial to terminal side, just like this. Now in this case, our theta is 180 degrees, and this also has a special name. This is called a straight angle. Kind of makes sense, doesn't it? All right. So now that we are a little bit comfortable with the degree measure, let's do some examples. All right, so let's go with, I'm just going to call this guy example 1. Draw each angle. All right, we got this. So let's do a couple of examples. So let's go with, how about negative 120 degrees. All right, so notice that the theta is negative. So if theta is negative, that means what? You're going to have to move clockwise from the initial side to the terminal side. Okay, so let me just draw it out. So what can we get over here? Okay, so again, I hope you can see this blue. Oh my gosh, I am the worst artist and I can never draw a straight line, just so you know. All right, so suppose this is going to be our initial side, and let's go with negative 120. Okay, so we know for sure that we're going to have to move clockwise. Now, let's notice that from initial side to here, that's just 90 degrees, isn't it? In fact, it's negative 90 degrees. And then you want to get to negative 120. So let's just think of in terms of, 90 plus what is going to give us 120. That will be 30, isn't it? 90 plus 30 will be 120. So what you need to do is you're going to have to revolve negative 30 degrees. A little bit more, like over here. Pretend that's like negative 30 degrees. And then we're going to draw our terminal side. So make sure to indicate the error. So this is arrow, sorry. So this is going to be our theta. So let me go with negative 90 plus negative 30 degrees. It's going to give us negative 120 degrees. So that will be the angle. All right, so now let's go with part B. How about 540 degrees? Okay, so notice that our theta is positive. So that means what? We're going to have to move counterclockwise. Okay, so keep that in mind. So now let me just try to draw this out. Okay, so again, our initial side is always gonna start from the positive x-axis. Okay, so let's go with 540. So first of all, one revolution is 360 degrees. So from here to here would be 360 degrees. But we need to get to 540 degrees. So from this point, how much more do I need to revolve towards the counterclockwise? So if I have, let's see, if I want to get to 540, and then I have already revolved 360 degrees, so the remaining is what, 180? So that tells me that from this point, I need to go 180 degrees more to get to its terminal side. So it looks like this is going to be our terminal side, and our angle theta is what's drawn in red. The next topic is convergence between decimal and degree, minute, and second. The notation for degree, minute, second is denoted by D circle, M apostrophe, and S double apostrophe. Okay, so the things that you must memorize is 1 minute equals 1 over 60 degrees. And 1 second is 1 over 60 minutes, which is what? 1 over 60 degrees times 1 over 60 degrees, which will give us 1 over 3600 degrees. Okay, and please also memorize that one counterclockwise revolution is 360 degrees. And 1 degree is 60 minutes, and 1 minute is 60 seconds. For this section, you are going to asked to convert the degree, minutes, seconds into decimals, and vice versa. So I think it's better to do it by the example, so let's get started. So I think this is going to be example 2, since we're still in the same section. So let's do a couple of examples. So let's call this one A. I'm going to ask you to convert 50 degrees, 6 minutes, and 21 seconds into decimal in degrees. Okay, so let me just first write it out as 50 degrees, 6 minutes, and 21 seconds. All right, so first step, what I would do is separate them. So this is same thing as what? 50 degrees plus 6 minutes, and then plus 21 seconds. Okay, so now let's go. Ready? So this is going to be I'll work this step by step. So this is 50 degrees plus 6 minutes is same thing as 6 times a minute. So 6 times 1 minute plus, and 21 second is same thing as what? 21 times 1 second. Okay, so now let me just circle what's important over here. Let's look over here. And what we're gonna do is we're gonna convert 1 minute into degrees, and then 1 second into degrees. So what you want to do is you want to look up here. Okay, so let's keep going. So this is same thing as 50 degrees. Now plus 6 times, now 1 minute is how many degrees? 1 over 60 degrees. And then plus 21 times 1 second is 1 over 3600 degrees. So this is same thing as 50 degrees plus, I'm going to multiply the 6 and 1 over 60 to get 6 over 60 degrees plus I'm going to do the same thing over here. 21 over 3600 degrees, which is going to be 50 degrees plus, that's what? 1 over 10 degrees, so which is what? Just 0.1 degrees. And then on 21 over 3600, please use your calculator. Let me see. As a side work, if I divide 21 over 3600, use your calculator, and this is going to be approximately 0.0058. Please tell me if I'm punching these values wrong. So in fact, since we're going to get an approximate value, let me just go ahead and be a little bit more precise and make the next step into approximately equaling to 50 degrees plus 0.1 degrees plus 0.0058 degrees. So add them all together. So this is going to be 50 degrees. Oh, sorry. Let me just go back. Putting it all together. So this is going to be what? 50.1058 degrees. And that's going to be our answer. Okay, then let's do another example. Okay, more example that we do, better we're going to get at this stuff. All right, so next step, let's convert, let me see, how about 98 degrees, 22 minutes, and 45 seconds into degrees. All right, so let's do the same thing. So first I'm going to write it out as 98 degrees, 22 minutes, 45 seconds, and I'm going to separate this. So this is going to be 98 degrees plus 22 minutes and then plus 45 seconds. Okay, so this is what? 98 degrees plus 22 times 1 minute plus 45 times 1 second. Okay, so we're going to do the same business as what we did above. So this is same thing as what? 98 degrees plus 22, and then 1 minute is 1 over 60 degrees, and then plus 45, and then 1 second is 1 over 3600 degrees. Hope you're kind of getting hang of it. Okay, so now use your calculator to approximate. Now, let me see. First, let's try to compute 22 over 60. Okay, if I punch that in, I get approximately 0.37. All right, so next step, what I'll do is, this is going to be approximately 98 degrees. Oh, sorry, I forgot this step. 22 over 60 degrees plus 45 over 3600 degrees. So, sorry, this should have been equal to. So now next step is approximately 98 degrees plus, let's keep it as 0.37 degrees, and then plus 45 over 3600 is what? 0.125 degrees. So add it all up together, we get 38.3825 degrees. And here we go. Okay, so for example 3, we're going to work it backwards from example 2. So what we're going to do is, given degrees, we're going to convert that into degree, minute, second form. All right, so I already wrote down the note above, just to remind us that 1 degree is 60 minutes, and then 1 minute is 60 seconds, which is same thing as 1 over 60 degrees, and 1 second equals 1 over 3600 degrees. All right, so I'm going to work this step by step. So let's get started. So let me just copy and paste 21.256 degrees. Now I'm going to separate this into 21 degrees plus 0.256 degrees. Okay, so now next step, what we're going to do is, let's keep it as 21 degrees. Now 0.256 degrees is what? 0.256 times 1 degree. So let me just separate it in that way. Okay, now let's take a look at this 1 degree. Okay, please look at the above note. 1 degree is what? 60 seconds. So I'm going to replace that. So this is 21 degrees plus 0.256 and times, this is what? 60 minute. 1 degree is 60 minutes. All right, so this is going to be what? 21 degrees plus, okay, if I multiply this out, what do we get here? 15.36 minutes. Okay, so now what we need to do is what? We got degrees and minutes. Now what we need to do is we need to squeeze out the seconds. Okay, so how do we do that? Okay, so let's go. Ready? 21 degrees plus, this is same thing, 15.36 minutes is same thing as what? 15 minutes, and then plus 0.36 minutes. I hope you can see that okay. All right, now we're gonna use that same trick as what we did earlier. So this is 21 degrees plus 15 minutes. All right, now 0.36 minutes is same thing as what? 0.36 times 1 minute. Okay, so now what we're gonna do is, we're gonna look at the note above in red, and I'm gonna circle what we need to convert. 1 minute is 60 seconds. So let's use that information. So we're gonna have 21 degrees plus 15 minutes, and then plus 0.36, multiplying here by 60 seconds. All right. Oh, sorry, maybe I should have wrote it like color coded. So this portion's gonna be, let me see, 60 what? Seconds. All right, so this is gonna be what? 21 degrees plus 15 minutes, and plus multiply this out, and what we get is 21.6 seconds. Okay, so now we're gonna put this all together. Now 21.6 seconds, approximately what? 22 seconds. So I'm gonna make this into approximation. So this is approximately equaling to 21 degrees, 15 minutes, and 22 seconds. And that is going to be our answer. Okay, so now let's do another example. So let's call this one example B. So what we want to do is we're going to convert. Let's do, how about 44.01 degrees into degree, minute, and seconds. All right, so let's start out with the same way. So let me just start out with 44.01 degrees. Now, let's separate. So this is 44 degrees plus 0.01 degrees, which is 44 degrees, and then plus 0.01 times it by 1 degree, which is 44 degrees plus 0.01, and multiplying here by 1 degree is what? 60 seconds? Oh, sorry, 60 minutes. Sorry about that. 60 minutes. 1 degree is 60 minutes. So there should be only one dash right there. So this is going to be what? 44 degrees. And if I multiply this out, what we're going to get is 0.6 minutes. Okay, so this is same thing as 44 degrees plus 0.6 multiplying here by 1 minute. Okay, so 1 minute is 60 seconds. So this is 44 degrees plus 0.6 times by 60 seconds. All right, we can do this. So this is 44 degrees. And then multiplying this out, this will be 60 times 0.6, 36. 36 seconds. Notice that, there's no minutes. So that means what? No minutes means 0 minute. So we're gonna have to insert that in. So this is same thing as 44 degrees plus 0 minute plus 36 seconds. Okay, so putting that all together, we're gonna get 44 degrees, 0 minute, and 36 seconds. And that's gonna be the answer. So do not panic if you're missing the minutes or seconds. You just consider that as a 0. Next topic in this section is we're gonna be learning about this thing called radian measure. Now, if I write DEF, def, that means definition, and then THM, that's short for theorem. Now, definition and theorems, you might want to memorize them because they are very important. But anyways, let's get started on this. So let's first go with the definition 1. A central angle is a positive angle whose vertex is at the center of the circle. Now, if R equals the radius of the circle, which is what? Length of the arc subtended by the central angle, then measure of the angle is called 1 radian. So I drew a little picture ahead of time. So in picture wise, that's what's going on. So notice the radius is denoted by R, and the theta is measured as 1 radian. Okay, and the arc length is denoted by S. All right. Don't worry, we're going to do some examples in a minute, but I just wanted you to get the visual picture of what 1 radian measure is. All right, so now let's go to the theorem, the arc length. For a circle of radius r, a central angle of theta radians subtends an arc whose length s is s equals r times theta. Now, the important thing is this. Theta must be in radians. Radian measure. Okay, so again, the best way to explain this is by example. So let's do example 4. I already wrote down the problem to just save us some time. So find the length of the arc of a circle with radius equals 3 meters and central angle is 0.35 radian. Okay, so let me just draw this out and see what the heck is going on, right? So pretend that's a circle. All right, now the radius is 3 meters. So from here to here is 3. Okay, and then let's just say that, hold on, let me change the color a little bit. Okay, so I'm gonna start out from here. That's the initial side, and the terminal side, let's just say it's over here. And radius over here is also 3. Okay, so our theta is between the initial side and the terminal side. Oh, I'm running out of room. I should have drew this a little bit bigger. So let's just call this central angle theta. And what you're asked to compute is how long is this piece of a circle, which is called the arc length. So this is our S. All right, so let's put it together. So what do we got? We know that arc length is radius times theta in radians. So this is going to be radius is 3 meters, denoted by 3m. And luckily we're given the central angle to be 0.35 radian measure. It's already in radian measure, so I'm just going to multiply that with 0.35. Okay, so what do we get? multiply that out, and I get 1.05 meters. So the little piece, the arc length of that circle on a little tiny piece is just 1.05 meters. That's what we just found out according to the theorem. Okay, the next topic is convergence between degrees and radian measure. Alright, so I already drew the picture to save us some time. So if I revolve around that whole entire circle, and let's just call that length S. So basically S is the circumference of the circle, which is what? S equals 2 pi r. But the thing is, we just went over the arc length formula. S, the arc length, is what? R times theta, where the theta better be in radian measure. Okay, but S is also the circumference of the circle. So S is what? 2 pi r. So I'm just going to replace the S with 2 pi r. And then here you're going to have r times theta. Okay, so now what? Let's divide it by r. We're allowed to divide it by r because r is the radius, and radius will never be 0. Doesn't make sense. So if I divide by r on both sides, what we're going to get is what? 2 pi equals to theta. Okay, so theta is in radians. Oh, radians. Nowadays I can't even spell. Sorry about that. Okay, so guess what? What we just discovered is this. One revolution is nothing but 2 pi radians. Well, one revolution around the circle is nothing but what? 360 degrees. So 360 degrees is equivalent to 2 pi radians. So please memorize this. This is very important. Okay, so since 2 pi radians is 360, 180 degrees is what? 360 over 2. So let me just write everything out. So that implies that if I wanted to compute how much is 180 degrees in terms of a radian measure. So this is what? 360 over 2. But 360 degrees is what? 2 pi radians. So this is just going to be pi radians. Okay, now for the radian measure, you know how it's tedious to write radians every time? So the shorthand notation is we just say pi rad. That denotes radian. That does not look like R, but that's a pi, R-A-D. Okay, so let me just box that. 180 is pi radians. Okay, so let me just write it directly below. We just discovered that 180 degrees is pi radian. I'm just going to leave it as pi rad. Now, if I divide this by 180 degrees on both sides, let's see what's going to happen. Okay, so that implies that what? What do we get? 1 degree is pi over 180 radian. Now, that is a very important thing that we must know, so I'm just going to box that in red. And on the other hand, let me just squeeze this in over here. Again, 180 degrees is pi radian. Now, what we just did earlier was what? We divided by 180 degrees on both sides, but we can also divide both sides by pi. So if I did that, let's see what's going to happen. Pi and a pi. Okay, so it looks like what? 1 radian is nothing but 180 degrees over pi. So here we get our convergence between degrees in a radian measure. Okay, so I'm just going to summarize everything below, so you might want to memorize this. So I'm just going to write memorize. Okay, so we got what? We talked about 360 degrees is 2 pi radians. I'm just going to keep it as rad. And 180 degrees is pi radian. And 1 degree is pi over 180 radiant. And 1 radiant is 180 degrees over pi. How's your brain doing? They all starting to look the same, huh? But you can always derive this in case you forget the convergence, just like what we did above. Okay, the next topic is area of a sector of a circle. I wrote down the formula, but before we do that, let's first practice how to convert degrees to radians and radians to degrees and vice versa. Let's do some example of that first before you get to the next topic. Okay, so let's call this one example 5. My handwriting's getting worse, sorry about that. All right, convert degree, oh my gosh. Convert degree to radians. Okay, so let's do a couple of examples. So let's call this one A. Let's go with good old 120 degrees. All right, so I'm going to convert that in terms of a radian measure. So this is what? 120 times 1 degree. Okay, but remember, 1 degree is how many radians? Pi over 180. Okay, keep that in mind. So this is same thing as 120 times pi over 180 radiant. So, which is what? 120 pi over 180, which gives us what? 2 pi over 3 radiant. So, 120 degrees is equivalent to 2 pi over 3 radiant. Okay, so now let's just do another one. Let's go with B. How about negative 450 degrees? Okay, so we're going to do the same thing. So this is what? Negative 450 times 1 degree. And so this is same thing as negative 450. Just like what we did above, 1 degree is pi over 180 radiant. So multiplying that together, you got what? Negative 450 pi over 180. Which is negative 5 pi over 9 radian. Okay, so here we go. So negative 450 degrees is negative 5 pi over 9 radian. All right, so that was example 5. Now let's do it the other way around. Let's go from radians to degrees now. Okay, so I'm going to call this one example 6. Okay, so we're going to go the other way around. So convert radians to degrees. Okay, so let's do another couple of examples of this. So let's go with 5 pi over 12. Okay, so 5 pi over 12 radians is how many degrees? Okay, so let's do this step by step. So this is what? 5 pi over 12, that's in radian measure, so this is times it by 1 radian. So this is what? So this is the same thing as 5 pi over 12. And then what? 1 radiant is 180 degrees over pi. Okay, so then this is same thing as what? You can cancel the pi's out. Kill the pi. All right, so then what do we get here? We get 5 times 180 degrees. Whole thing dividing by 12, which is what? 75 degrees. And there you have it. So 75 degrees is same thing as 5 pi over 12 radians. Okay, so let's go with part B. Negative pi over 6. Okay, so we're going to do the same thing. So this is negative pi over 6 times by 1 radian. So this is same thing as negative pi over 6. And then again, 1 radian is 180 degrees over pi. Okay, so this is same thing as, well, again, kill the pi's again. Kill. All right, and then what do we get? Negative 180 degrees over 6, which is negative 30 degrees. Okay, so it looks like pi over 6 is equivalent to 30 degrees. Now we're going to have to memorize all those standard ones later on. So for now, memorize that pi over 6 equals 30 degrees. Okay, so I think we are ready to go to the next topic, which is the area of a sector of a circle. So I've already drawn the picture for you right there. Now, area of the sector of the circle is shaded in blue, and R stands for the radius, and theta must be in radians, and the formula is area of the part of the circle is 1/2 r squared times theta, where theta is in radians. Okay, so example 7, let's try something like this. Find the area of the sector of a circle with r equals 3 feet and theta equals 120 degrees. Okay, so I already drew the picture ahead of time. So let's write down the formula. Area of the sector is 1/2 r squared times theta, but be careful, theta must be in radian measure. Okay, so first what we need to do is what? Since we're given the degree, 120 degrees, so first we need to convert that into a radian measure. So let's first go with theta equals 120 degrees, which is what? 120 times it by 1 degree, which is 120 times it by 1 degree is what? Pi over 180 radian. And simplify, then what do we get? 2 pi over 3 radian. Okay, so we just converted the 120 degrees into a radian measure. So now I think we're ready to plug and chug into this equation to get the answer. So therefore, oh, by the way, these 3 triangle dots means therefore in a math class. All right, so I use that quite a bit. So therefore, A equals 1/2 r squared theta now becomes 1/2. R is what? 3 feet. So you're going to have 3 squared times it by theta is 2 pi over 3. Okay, so this is same thing as what? 3 squared is 9. 9 over 2 times it by 2 pi over 3. Now let's simplify a little bit. 2 is going to cancel. 3 goes into 3 once and into 9 3 times. Okay, so it looks like this is going to be, what, just 3 pi? Now if you punch that in the calculator, 3 times pi, this should give you a decimal approximation. So this is approximately 9.425 square feet. So the little shaded portion of the area is approximately 9.425 square feet. Okay, so let's do another example, but something a little bit different. So let's go with part B. Okay, now suppose you're given that radius of the circle is 6 meters, and then you know the area. Area is given to be 8 square meters or meters squared. Now what I want you to do is find theta in radian measure. Okay, so find theta. Okay, so what we're going to do is this. First, let's just start out with the formula. So we have A equals 1/2 r squared times theta. But A is 8 square meters equals 1/2, and the radius is 6 meters squared, and then multiplying here by theta. Okay, so simplify that a little bit. So we get what? 8 square meters is what? 18 square meters. Is that right? 6 times 6 squared m squared and dividing by 2. Yeah, so it should be 18 square meters times the theta. Alright, so now we should able to, since we're solving for theta, let's divide both sides by 18 square meters, 18 square meters. Okay, so it looks like that implies that theta equals to what? 8 over 18. Now punch that into your trusty calculator. Well, theta is what? Reduce that into 4 over 9 and type that in the calculator and I get 0.44, and this is better be in radian measure, so our angle theta is 0.44 radians. So I think that's pretty much it for section 7.1. Please let me know if you have any questions. Okay, so let's get into section 7.2, right triangle trigonometry. Okay, so I've already wrote down what's important, so let's just go over this. So suppose that theta is an acute angle. So what is acute angle? So the angle better be between 0 to 90 degrees. And that's in degree measure, so that's same thing as what? And equivalently 0 to pi over 2 in radian measure. Now, let's draw the, I've already drawn the right triangle there. Now, if the theta is denoted by where it is, the adjacent side of theta, I'm going to call that by A. And the opposite side of the angle theta is denoted by O. And you know the good old hypotenuse, which is denoted by H. Okay, so this next part is something that's very, very important that you're going to have to memorize. Now, we're going to come up with the 6th ratio of the length of the sides of a right triangle. Now, those are called the trig functions of an acute angle, defined by, all right, ready? Sine of theta is denoted by sine parenthesis theta, that's called sine of theta, is opposite over hypotenuse. Now, cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. And cotangent is the 1 over tangent, which is adjacent over opposite. Secant of theta is the reciprocal of cosine of theta. So it's going to be hypotenuse over adjacent. And cosecant of theta is denoted by CSC of theta, is the reciprocal of sine of theta. So since sine of theta is opposite over hypotenuse, it's going to be hypotenuse over the opposite. All right, so what I wrote on the right hand side is the reciprocal identities, which you're going to have to memorize. So follow the green arrows. So notice that sine theta and the cosecant of theta is connected with the green arrows. So those are the reciprocals of each other. So the cosecant of theta is 1 over sine of theta. And secant of theta is 1 over cosine of theta. And the cotangent of theta is 1 over tangent of theta. Okay, so you might want to write this down and memorize it. Now, do you see it on the bottom? I have so, ka, toa. Okay, so that is not a foreign language. Well, maybe it sounds like a foreign language. But that stands for, S stands for the sine. Sine is opposite over hype. Let me just go through this again. So the sine is opposite over hypotenuse. Cosine is adjacent over hype. And the tangent is opposite over adjacent. A lot of students memorize SOHCAHTOA, so that way you can easily memorize, sine is opposite over hype, and cosine is adjacent over hype, and tangent is opposite over adjacent. But if you misspell that, you see what's going to happen, right? So make sure to spell that out correctly if you're going to use SOHCAHTOA. Okay. Okay, so what I just wrote on the top is SOHCAHTOA. If you missed it, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, now another thing that you're going to have to memorize. I know you're going to have to memorize so many things. All right, it's called the quotient identities. Let me just, forgot the T there. So quotient identities. Please memorize that tangent of theta is sine theta over cosine theta. And cotangent of theta is cosine of theta over sine of theta. Okay. So let's do some examples. Let's go with example 1. I already wrote down the problem to save some time. All right, so example 1, find the values of the 6 trig functions of the angle theta. Okay, so basically what the question's asking is find sine of theta, cosine theta, tangent theta, cotangent of theta, secant of theta, and cosecant of that theta. All right, so let's get started on this. So first, given the adjacent side of that, the angle theta is 2, opposite side of the angle theta is square root of 3. So first what we need to do is, what the heck is our h? Okay, so all you have to do is what? Use the Pythagorean theorem. So you're going to have what? H squared equals 2 squared plus square root of 3 squared. Okay, so h squared is what? 4 plus 3, which is 7. So our h is really plus or minus the square root of 7, but h is a length, so there's no way in heck that h can be negative. So our h is positive square root of 7. So let me just erase and write that out. So the h is square root of 7. All right, so I think we're good to go. So let's get to work on this one. So let's go with sine of theta. Okay, so sine is what? Opposite over hypotenuse. So which is opposite side of the angle theta is square root of 3. Hypotenuse is square root of 7. Okay, now let's go with cosine. Cosine of theta is what? Adjacent over hypotenuse. Adjacent side of the angle theta is 2. Hyp is square root of 7. And tangent of theta is opposite over adjacent, which is square root of 3 over 2. Now let's go with the cotangent. Cotangent is what? 1 over the tangent. So which is, what was tangent? So it's 1 over the square root of 3 over 2. So this is what? 2 over square root of 3. And secant of theta is 1 over cosine, which is 1 over cosine was what? 2 over root 7. So this is root 7 over 2. And cosecant of theta, using the reciprocal identities, is 1 over sine of theta, which is 1 over root 3 over root 7. So this is root 7. Oh my gosh, that's a 7 over root 3. And there you have it. So those are all the 6 trig functions of the angle theta. So let me just box that for the final answers. And there you go. Okay, now in trig class, we're gonna have to memorize so many things. I remember I suffered a lot because I'm not very good at memorizing things. So I highly recommend that you make a little note card or something like that and just go over this every single day till you memorize it. All right, so next thing that you're gonna have to memorize is this thing called the Pythagorean identities. So let me just write it out. And you're gonna see this a lot in trig class. So first, please memorize that. sine square of theta plus the cosine square of theta equals to 1. And tangent square of theta plus 1 equals secant square of theta. And cotangent square of theta plus 1 is cosecant square of theta. Alright, so these are called the Pythagorean identities, which you are required to memorize. Okay, so I've already wrote down the next two examples that we're going to go over. So let's just first start out with example 2. Use identities to find the exact value of each of the 4 remaining trig function of theta. So for this example, we're given sine of theta is 1/3 and then cosine of theta is 2 root 2 over 3. So our job is to find all the rest of the trig functions, which is tangent, cotangent, secant, and cosecant. So let's get started on this problem. Okay, so basically if you have sine and cosine given to you, you can basically derive all other 4 trig functions. This is why. Okay, so we got sine, cosine, next is what? Tangent. So tangent of theta is what? Sine over cosine. Tangent is sine over, cosine. Okay, well sine is 1/3. Cosine is 2 root 2 over 3. So the answer is what? 1 over 2 root 2. So that is the value of tangent of theta. Now let's go with the cotangent. Cotangent of theta, reciprocal identity for that is what? 1 over tan of theta, which is, we just computed the tan of theta, so this is 1 over 2 root 2. So this is just going to be 2 root 2. And let's go with the secant. Secant of theta, what's the reciprocal identities for that? That's 1 over cosine. So which is 1 over cosine is given to be 2 root 2 over 3. So this is 3 over 2 root 2. And secant, and next is what? Last one is cosecant of theta. Reciprocal identity for that is 1 over sine of theta, which is 1 over 3. So which is going to be just 3. And here you have it. For the next example, let's call this one example 3. Find the exact value of the remaining trig function of theta. So in this case, you're just given one trig function, which is secant of theta equals 5 over 3. Okay, so let's see what we can do with this. Okay, so first note that secant of theta is what? Reciprocal identity for the secant is 1 over cosine of theta. Okay, but the thing is, cosine is what? Adjacent over hypotenuse. So 1 over that, so it's going to be what? Hypotenuse over adjacent. Okay, but secant of theta to be given by 5 over 3. So let me just insert that. You're given that this is 5 over 3. So that means what? Hypotenuse better be, of the triangle is 5, and an adjacent side of the right triangle better be 3. So let's draw that out and see what we're going to get. So pretend that this is the right. Oh my gosh, I told you I'm a horrible artist. Okay, so this is our angle theta. So what you just found out is what? Hypotenuse of this triangle has length 5. Adjacent side of the angle has length 3. So question is, what is the opposite side? Okay, so let's call the opposite side to be y or something like that. So I'm just going to denote this by y. Let's find the value of y. By the Pythagorean identities, we know that what? Y squared plus 3 squared better equal to 5 squared. Okay, so then what? Y squared is 25 minus 9, which is 16. So y is going to be plus or minus the root 16, but it's a length, so y is going to be 4. So this length right here is 4. Okay, so I think we got the triangle going on here, so I think we should be able to get rest of all the trig functions. All right, so let's go with sine of theta. All right, sine of theta is what? Opposite over the hype. Opposite side of the angle theta is 4. Hypotenuse is 5. And here we go. Next one, cosine. Cosine is adjacent over hype. Adjacent side is 3. Hypotenuse is 5. So the answer is 3/5. And let's go with sine, cosine, tangent. All right, so tangent of theta is SOHCAHTOA, right? So it's opposite over adjacent, which is 4/3. And the next one is what? Cotangent. Well, cotangent is 1 over tangent. So which is what? 3/4. And secant. Secant is 1 over cosine. So which is what? 5/3. And cosecant. Cosecant is 1 over sine of theta. And so this will be what? 5/4. Okay. Oh, wait a minute. Secant of theta was given to us, huh? Oh, well. And here you have it. The next topic is complementary angle theorem and also the cofunction of complementary angles theorem. All right, so let's first go with the complementary angle theorem, which I drew it out for you already. So suppose you're given the right triangle. Now, we're going to have two angles, angle B and angle A. Now, angle B is sandwiched between little a and a C. Angle A is sandwiched between little c and a b. So keep that in mind. So let's go with sine of B. Now, sine of B is what? Opposite side of B over the hypotenuse of the triangle. So that will be what? B over C. But let's look at B over C. Now, from angle A's point of view, isn't that nothing but the adjacent over the hypotenuse? So who's got the adjacent over hype? It's cosine. So basically what we're going to get is sine of B is given by little b over c, which is same thing as the cosine of the angle A. Okay, now let's go with cosine of angle B. Cosine is adjacent over the hypotenuse. So the adjacent side of angle B is A, hypotenuse is C. So we got cosine of B is A over C. But isn't that same thing as sine of the angle A? Because sine is what? Opposite over the hypotenuse. So the opposite side of the angle A would be A, little a, and the hypotenuse is C. So therefore cosine of B equals sine of A. Now we're going to do the same thing. Now tangent of angle B, tangent is what? Opposite over adjacent. So the opposite side of angle B is the little b, and the adjacent side of angle B is little a. But that's same thing as what? Cotangent of angle A. Okay, so keep that in mind then. By using the reciprocal identities, cotangent of B is 1 over tangent of B, which is going to be A over B, little a over B, which is tangent of angle A. Secant of B is 1 over cosine of angle B, which is C over A. And that's same thing as cosecant of A. And cosecant of angle B is 1 over sine of angle B, which is C over little b, which is the equivalent to secant of A. All right. So now, please let me know if you have any questions on that. I know that, looking at the triangle upside down and stuff like that gets kind of confusing. But let's go into the next theorem. Next theorem is the cofunctions of complementary angles are equal. Okay, so the cofunction means, if it's a sine, what's the cofunction of sine? It's cosine, right? So cofunctions are sine and cosine. Now, what's the cofunction of tangent? Cotangent. It's a cofunction. Okay, similarly, secant, what's the cofunction of secant is cosecant. All right, so please note that complementary angles means theta 1 plus theta 2 equals to 90 degrees. So if you two complementary angles means that when you add those two angles, it's going to add up to 90 degrees. So according to the theorem, sine of 20 degrees better equal to cosine of 70 degrees, because 70 plus 20 equals to 90. Now, tangent of 30 degrees is equivalent to cotangent of 60 degrees. Again, 30 plus 60 is 90, and then suppose we got secant of 15 degrees. Now, the cofunction of secant is cosecant. Now, 15 plus what's going to give us 90 is 75 degrees. So, secant of 15 degrees equals cosecant of 75 degrees. Please memorize that theorem. So, in summary, for the theorem of cofunction of complementary angles are equal means that sine of theta equals cosine of 90 degrees minus theta, because if you're given theta, what's its complementary angle? That's nothing but a 90 degrees minus theta. So that's in degree measure. So in terms of a radian measure, 90 degrees is the same thing as pi over 2. So that's equivalent to saying cosine of pi over 2 minus theta. Now cosine of theta, cofunction of that is sine of theta. So cosine of theta, its complementary angle of theta will be 90 degrees minus theta again. So cosine of theta is sine of 90 degrees minus theta. That's equivalent to sine of pi over 2 minus theta in radian measure. And the cofunction of tangent is cotangent. So the same rule applies. So therefore tangent of theta is cotangent of 90 degrees minus theta, which is cotangent of pi over 2 minus theta. And so forth. You can follow that through. So cotangent, secant, and cosecant of theta, they apply the same rule. Okay, so let's do some examples using this theorem. So example 4, find the exact value of secant of 27 degrees and then minus cosecant of 63 degrees. Okay, so all right, so first step, let's see, 27 degrees and 63 degrees. Are they complementary angles? I believe so, because 27 degrees plus 63 degrees equals 90 degrees. So therefore, those two angles are complementary. All right, so that means what then? If I try to simplify this, let's just leave the secant of 27 degrees alone, and then let's convert cosecant of 63 degrees into what's the cofunction of cosecant? That's nothing but secant. All right, so notice that, so I'm gonna work it on the side. Note that cosecant of 63 degrees is secant of 90 degrees minus 63 degrees, which is secant of 27 degrees. Okay, so keep that in mind. All right, so we got what? Secant of 27 degrees minus, now cosecant of 63 degrees, we just found out that's nothing but secant of 27 degrees. Now, since we're subtracting the same thing from each other, your answer is going to be 0. So that is it. Maybe we can do another example of it. So let's take a look at something a little bit more involved. So let's call this one B. So let's see, what can I come up with? So how about secant of 27 degrees? Nah, we just did that one. So let me just change that. Okay, so what can I come up with? Let's do another secant then. So secant of how about 35? Secant of 35 degrees, and then cosecant of 55 degrees minus tangent of 35, and then cotangent of 55 degrees. Okay, so let's get to work. So first thing, note that, let me just change the color so you see it better. So note that 35 degrees plus 55 degrees, they're going to add up to 90 degrees. So therefore, they're complementary angles. So I'm just going to write it, therefore, they're comp. All right, so with that said, it doesn't really matter which one you're going to convert, but how about I'm going to keep that first secant of 35 degrees, and then let's use the theorem to convert the cosecant of 55 degrees into, in terms of cofunction of cosecant is secant. So let's convert that in terms of secant. So as a side work, note that cosecant of 55 degrees is secant of, what is that, 90 degrees minus 55 degrees, which is going to give us secant of 35 degrees. Okay, so let me just work that out. So this is same thing as secant of 35 degrees. And then this portion now becomes also the secant of 35 degrees. Okay, and then minus, let's keep the tangent of 35. And then what? Cotangent, cofunction of cotangent is tangent. So we're going to do the same thing. So this portion is going to become what? Tangent of, what's the complementary angle to 55 degrees is 35 degrees. Okay, I hope you can follow my work all right. So let's simplify this a little bit. So this is what? Secant of 35 degrees times itself. So that's what? Secant squared of 35 degrees, and then minus, same thing, tangent squared of 35 degrees. All right, so we're going to be using a lot of theorems here. So note, remember the Pythagorean identity? So note that tangent square of theta plus 1 equals secant square of theta. All right, so with that said, secant square of theta minus tan square of theta is going to give us just 1. All right, so in this case, our theta is 35 degrees. So guess what? All that work to determine that answer is 1. From this step to this step is followed by this theorem right here. Okay. Okay, let's do some different types of a problem here. So example 5, given cotangent of theta is 2, use trig identities to find the exact value of tangent of theta. You know what? Let's do a few examples by using this. So let's just call this one A or something like that. All right, so let's get started on this one. So you're only given that cotangent of theta is 2. Okay, so I want to find the tangent of that angle theta. So first, tangent is what? 1 over the cotangent of theta. Okay, but the cotangent of theta is 2, so here we're going to have 1/2. Now on the other hand, tangent in SOHCAHTOA is what? Opposite over the adjacent. Okay, so that means that, let me just draw my, oh, this triangle isn't too bad. All right, so anyways, if I call this angle theta, this is telling me the opposite side of this angle theta better have length 1. Adjacent side of theta has length 2. Okay, so applying the Pythagorean theorem, then here your h is going to be what? H squared equals 1 squared plus 2 squared, so h is square root of 3. Okay, so keep that in mind. So our tan of theta is going to be 1/2. So that was already our answer, but I went ahead and drew our triangle to see what's going on. All right, now let's go with part B. All right, so let's try to find out cosecant square of theta. Okay, you're only given the cotangent of theta is 2, so what can we do? How about a Pythagorean identity? Cosecant squared is what? Cotangent square of theta plus 1. So which is what? 2 squared plus 1. So our answer is 5. Okay. So now let's take a look at C. How about tangent of pi over 2 minus theta? Okay, so now it looks like we're going to have to use our cofunction here. So complementary angle theorem says that tangent, cofunction of tangent is cotangent. So this is same thing as cotangent of theta. Okay, well, cotangent of theta is given to us. That's nothing but 2. So this is our answer. Let's do another one. Let's do just one more. Okay, hang in there. So D, let's go with secant square of theta. Okay, now Pythagorean identity says what? Secant squared is tan squared plus 1. Okay, now from part A, we already computed the tangent. Tangent of theta is 1/2. So here you're going to have 1/2 squared plus 1, which is 1/4 plus 1, which is going to be 5 over 4. And there you have it. And that is the end of section 7.2. Again, if you have any questions, please let me know.